Hi, Karna.
Hi, how are you?
I'm good. How are you doing?
Ah, I'm fine. Okay, I'm busy inviting people now. Just a
Okay,
moment. Let me invite,
sure.
remind them. So,
Hello, Ajay, Michael. Hi, Mary. Welcome.
oh, awesome. Welcome, Prince, Jai, Michael, Rufina.
So hello, everyone, from my side too. I think we'll wait until maybe 2 minutes and then we'll start with someone
Sure.
else.
Yeah, thank you.
Hello, Dylan. Welcome.
Welcome, Dylan. Yeah,
Okay, so let's start then. Welcome, everyone. So today we have planned to discuss about the common vulnerabilities in Cardano. So, for example, you are thinking about the app development, and considering the fact that you'll be knowing all the basics of Cardano's protocol, there are still more chances of having a vulnerability the way we code. So it would be a very critical topic today. So let me share my screen. Are you able to see my screen? Yeah. Um, okay. So let's start. So today, this goal of is to provide a comprehensive overview of the common patterns that can lead to security weaknesses when you are thinking about developing a decentralized application. This is a critical topic because I myself is an auditor. So we have this list of vulnerabilities that we refer to whenever we audit any application that is built on Cardano. So this is like a reference. And this presentation is a curated list of some of the most common patterns, and I'll also share you a link which has given an inspiration to do this, a presentation today. Let me quickly share that. Okay. So the content of this presentation is drawn directly from this guide, which I've shared. It's created by the MLabs team, but it serves as an excellent resource for any developers and auditor. You could refer to that because it has all the list of vulnerabilities that we see whenever we look into an application for its securityness. So yeah, so before we start, it would be a good idea to just have a recap of the basic terminology. Uh, so yeah, first we'll go with address. As you would already know, a Cardano address will have two to three components. The first component is the header. Uh, Give me 1 second. Okay, yeah. The first component is the header. It refers to the network that we are using, like the testnet preview or the mainnet, and also the type of address, like whether you have only a payment credential address or you also have a staking credential address. So you have the type of the address in the header. And the next component is the payment credential. It actually contains either a verification key hash or a script key hash. So when you use that address as a wallet, it's going to be only a verification key hash. Or if that address is going to be a script that is like a validator, then you'll be having the script hash at this part of the address. And this is the delegation credentials part, which is like an optional, but is highly recommended. And this will be used for, when you stake the rewards and also to publish the certificates of what you are going to use. So these are the major three components of an address. After that, the other important point to note is an EUTXO model. So we all know about a UTXO model, like you're going to pick all the outputs that are available to choose, and you're going to spend it wholly, which is actually going to be an input. And then the output is the unspent transaction output. So this is how it's working. But when we say it's an EUTXO, the other extra component that we consider is the datums and the redeemers. So when we call anything as a script, that's actually a validator that validates your transaction. So you could consider any logic that's going into the transaction, but the answer is going to be a yes or a no. So we usually say this term predicate, meaning that it just gives a value as a true or a false. So that's the reason we say that as a script. And yeah, looking at this diagram, so this is how a transaction is going to be. You have an input UTXO, which has the reference of the transaction that is being used. And then there is a component datum where you're going to add the value that is going into the transaction. And then you will have other assets like any tokens and any script references. Once this is consumed, the consumable logic also depends on the redeemer. So that's why I've put the diagram like this, considering the fact that redeemer is used or it tells you how to spend the output. Like you might have a project or a protocol where you have these kind of endpoints, like you add money to a wallet or you update the money that is already existing there. So these are considered like a redeemer. So you actually tell the instructions on how to spend the UTXO. So this is a redeemer. And then the output UTXO is going to be very similar to the input UTXO. It is same, but the whole transaction is what makes it, to look in a different way. So this is the basics of it. So once you are at this point, you understand what an address is, what an UTXO is, and then you start building your decentralized application, and that's when you write the on-chain and the off-chain code. So this vulnerability list that I'm talking about today is about the logic that you use to build your on-chain code. So here, uh, it is actually a huge list, but what we have to focus is on the property statement and if there are any tests and what is the impact it's going to have. For this simplicity of this session, I am considering to look at the property statement, the impact that particular vulnerability will have, and also a basic theoretical explanation of prevention, how you could prevent while building your on-chain code. So this is how our structure is going to be. Okay, so let's, okay, before that, okay. So the list of impacts. So when you have, when you say impacts, this classification actually helps us to quantify the severity and nature of the security flow. Um, so, like I said, I'm an auditor, so I audit Cardano projects. And what we do is we have this list of vulnerabilities, and we also provide the severity of each finding. And that is based on the impact that it's creating. So, for example, if there is a protocol and we have built an on-chain code, and that on-chain code has the possibility to stall the protocol, or you could, never take the funds out of it. That is when it's going to be, a severe critical situation. So this list of impacts actually helps us to classify the findings based on the severity. And also, when we talk about the vulnerabilities, we'll understand why that vulnerability has this impact. So yeah, So bypassing checks means you skip a security requirement, and leaking protocol token implies that there is a token that is assigned to a protocol, but there is an unauthorized transfer of that uh, token. So this is an impact. It shouldn't supposed to be done, but it is if your code allows it, so that has to be checked. And unspendable outputs is like a deadlock situation. You can never take the funds from it, and the entire application is standstill. So these are some of the impacts. So we will start with the list of vulnerabilities. Uh, I will also quickly share another few links which has a very easy way of explaining the basic addresses and inputs, outputs, how a transaction works. And there is also a quiz once you complete that, which is also going to be helpful. Okay, I have shared the links. So yeah, sorry, the first vulnerability is called other redeemer. What happens here is you have a script and you have a redeemer a logic for that, but that logic relies on the logic enforced by the other redeemer. That could come from the same script or a different script. If that that logic of the redeemer that has been relied on, if it is not verified, then it's going to be an issue. I can better explain with this example. Uh, is my screen visible and clear?
yeah,
Okay. Okay. So yeah, let's take this example. We have a user and we have a simple staking protocol that allows users to lock a certain amount of token and later on receive an ADA reward, which increases based on the amount of time tokens have been locked. So this protocol will have to contain two validators. One is the global validator, which I would say its mission or the validator's mission was to lock an NFT that carries a datum because it's going to carry a value of the global state of the code. And this position's validator's mission is to lock one UTXO from each participant, from each user, holding the user's bag of tokens. And that UTXO will carry a datum as a timestamp, stating that when was the last time that position was updated. So these are two validators. And as I said, the datum will be a global state for this, and it will be a timestamp of the last position that got updated. So to interact with this validators, you can either open a position or you can update a position. Let's assume we have an update state redeemer here, and this checks a position is opened or updated correctly, and then rewards are distributed. And this position validator has one redeemer, which is update position, which checks that the NFT locked here in this global validator has been consumed. So therefore, the check that you use to lock the UTXO at this point, it's already checked, and you have an NFT, and this relies on this redeemer. Suppose there is another redeemer that we add to here, like add rewards. And this only checks, for the ADA increase. Like it consumes the UTXO, it locks in an NFT, but this UTXO is consumed only to increase the ADA, meaning that this update position has never happened. And in this case, anyone can use the update state with a fake timestamp and take the funds. So this is one major vulnerability. I hope this image was clear and it's easily understandable. Yeah. So for this, as a prevention or a solution that okay, maybe I'll go back here, that we look for in the as a recommendation for that finding is to you should explicitly mention what all the expected redeemers are wherever possible. So once you audit some projects and you find that there is a redeemer that is dependency on the other redeemer, you have to check whether it has been explicitly mentioned. I would say this is a theoretical way of presenting how you can solve this, but once you get into coding, and I think it's going to be an easy way of understanding. And the next one is other token name. Okay, so let me see if I have it. Okay, I have it here. So here, uh, this other token name, I would say it arises in minting policies because it's about the token name. And it is often coming from the point that there is an incomplete understanding of how tokens are defined on Cardano's. Sorry, Cardano. So when you say a token, it is just about a currency symbol. That is, you have a minting policy, and the hash of the minting policy is what the asset class is. So when we say a token, we have to consider the asset class, the token name, and the quantity of it. If you have a logic like this, like when you code and if you check the asset class value of the minted token, and if you equate that to some quantity, you're only checking on the asset class, meaning the currency symbol, that is the hash of the minting policy and the specific token name. But this pair should be equated with the amount of tokens that this pair is being generated. So that is one major thing to consider. You should, yeah, like this is the simplest fix. That's what it says. You have to check the mint is of this own asset class and also it has the same quantity that you intended to mint. This, no, this clearly explains because this checks only the asset class, but this one is it checks the asset class and also the quantity of the token it minted. That is one major aspect to be seen here. Uh, okay, just verifying if everything is okay, and I'll continue to proceed. Any doubts so far or any feedback?
Awesome.
Okay, so let me continue. Uh, okay, okay. Give me 1 second, please. Okay, sorry about that. So when we, okay, we let's go to the arbitrary data. So when we say arbitrary datum, it means that uh, the datum that you're attaching as an input is correct. We are, when we say it's a datum, we are free to attach any type of input into it. But the UTXO, when we consider consuming the UTXO, we shouldn't give any wrong information into the datum. So that is what an arbitrary datum means. Um, when I remember this happening in one of the cases where they skipped checking the datum of an output being locked if they don't use that specific datum. Like they don't use that specific datum, so they just put like a void, and when they use it in the future validation logic, then it's going to fail. So you should always make sure the type of the datum must still be the same as the validator's expectation. So if there is a mismatch, you should ensure that the code mentions that the type of the datum is mistake, or the way you have given the datum doesn't sync with what my validator expects. So that check has to be there in on chain code. And also to mention again, this has a bigger impact because when there is a mismatch in the datum, the output or the UTXO is going to be unspendable. We can't spend that UTXO and the funds will be locked forever. That is one major concern here. And then the unbounded datum. Mm, mm. So yeah, for the unbounded datum, so now we have crossed the point that we have make sure, we made sure that the datum type is correct, and this is what a validator expects. And there are a few criteria to consider, inside the data. So when you say unbounded, uh, you're saying something that you haven't put a restriction on where it is needed. So here it says the property statement says that the datum for all legit UTXOs locked by the protocol have an upper bound for their size, meaning that you are having the protocol where you collect a list of users. And if you don't put a hard stop on the number of users, and every time that UTXO is being consumed, you're going to add one more user to the UTXO. This is actually going to blow up the whole protocol at some point. So if you have like 100 users and it keeps on adding each user, it's going to be a big UTXO to consume. So you will achieve the transaction limit. This is also going to impact on the protocol halting and also unspendable output. So let me check if I have an example. Yeah. So here, if you see, this is a datum that we have initialized, and I have a user, which is a list of string, and a user to public hash that I think doesn't apply to our case right now. But this list of users is a string. It's a list of string. Okay, so it then is when there's going to be a list, you don't have a restriction on the amount of users you're going to enter. So you have to make sure that this datum that you're using has a hard stop whenever you code. So you have to mention that the maximum amount that the list of users can be 10 or 20. Or if goes above the specified limit, then you have to put a trace error mentioning that it has exceeded what my protocol expects. Okay. This unbounded value is very similar to unbounded input, unbounded datum, except that it means the size of the token within the UTXO. So first thing is the datum, and as you saw, we had an asset, and the asset is going to be any token. So the size of the tokens within an UTXO should also be carefully chosen. That should also have an upper bound. This also leads to no, unspendable output because all these leads to the transaction execution limit, or even you could say transaction size. So always have an higher constraint about the datum and also the value used in the number of tokens. Okay, I would actually talk about a few scenarios where I know this is a problem. So if your script expects an exact count and an in exact count of tokens and an input comes with an unexpected extra token, then it will fail. This is one scenario. And the other scenario is when you have many native tokens that are carried in a transaction, it will obviously push the transaction limits. So you should be careful about choosing the inputs with native tokens. Or if you have a script and it iterates through all the tokens in an UTXO. So you have many UTXOs and it has to go through all the tokens in an UTXO. That is also where it will exhaust the resources. So this also should be taken care of. As a prevention, yeah, what we could do is to explicitly constrain the values that the script accepts. Like you have to put a condition where my script is expecting only this amount of tokens or only this token. Uh, Maybe to put it in a clear way, I would say don't just expect that the expected tokens are there. Ensure only the expected tokens are there. I think there's a difference, between the two statements. So we have to just have a logic to, to just have only the expected value of the tokens. Okay. And then is the unbounded inputs. Okay. Okay. This comes in when you choose inputs as the input UTXO above what you could actually take. You can have one UTXO that is actually supplying your input transaction fees. But if you have two to three other UTXOs that are being used as a script reference or even as a collateral, it adds to the number of UTXOs. But what if you have to collect from a lot other UTXOs? That is where this unbounded inputs is a problem. Um, Maybe we can let's check if I have an example. Okay, if not. So maybe we'll consider a faucet, yeah, like a testbed faucet or something, where we have to distribute 100 ADA per claim, and the remaining balance is returned to the faucet's address. So usual implementation might allow that remaining balance to be split into small outputs. But over time, if the faucet funds are fragmented into thousands of UTXOs, then to make a subsequent 100 ADA claim, script must actually combine all these large number of, not large, I would say, yeah, large number of small inputs. So this will actually exceed the transaction size, memory, and also making the funds effectively unspendable. So to prevent this, it's very crucial to enforce a structured input-output pattern. For example, ensure that a script only consumes a script input from itself. So it's like a own input. Always consolidates the remaining value into a single output back. So, it's mentioning about how you have to um, use the single input from itself and to single output back to itself. So this way you will actually prevent that fragmentation and also keep the number of inputs manageable. The next one is multiple satisfaction. This one is quite uh, quite easy, or I would say maybe subtle to understand. So it occurs when a script's logic correctly validates the consumption of a single UTXO, but fails to account for what happens when multiple UTXOs from the same or different scripts are consumed. Hope I put it in a understandable way. It's maybe yeah, we'll go through the property statement once. So all scripts consider the totality of inputs to the transaction as well as the totality of minted value and value withdrawn from staking validators when allowing spending, minting, or withdrawing value. So what I was initially trying to say is the script's logic validates the consumption of a single UTXO, but it should all it will fail to account when there are multiple UTXOs that are coming from the same or different scripts. Uh, I don't have an example here. So let's consider a validator that simply ensures that whatever value was consumed from its own input is returned to it in an output. So if an attacker consumes two UTXOs from this validator in a single transaction, they could return only one of the required outputs back to the validator. So that's what I said. No, consuming of the single UTXO is taken care of, but wouldn't have given any logic to to skip or to account for the multiple UTXOs. That is one a problem here. So this solution is to for this case is to consider the transaction as a whole. Your script must verify not only the expected inputs are present, but it also should make sure that there are no unintended inputs that are included to your script. That is a major, solution to check for in the code. And let's see. Okay, this is a missing UTXO authentication. Okay. So this usually it is about trusting the source of data. It says the property statement says all spending and referencing of the legit protocol outputs is authenticated. Okay, but what it means is, for example, if we have to rely on an external source of data like an oracle to get a value, that is where this vulnerability pops up. Um, let's take an example of an insurance protocol where they pay out if a natural disaster occurs. So in this case, it will use an oracle. That oracle will be publishing the disaster date in the UTXO. Let's say we have this oracle validator address. So it's going to have an UTXO with the disaster date. If we check uh, only if there is a UTXO that's coming from this oracle address, and if we read the datum, then it's going to be a mistake. Anyone can put any value as a datum, and it can be a false information. So we could consider the UTXO to be legitimate, but the value inside the datum might be false. So in order to as a prevention method, what they usually do is to have a non-fungible token, that is an NFT, attached to this UTXO that we are consuming. So we could make sure that this I mean, for example, if that transaction has an Oracle NFT, we'll be checking whether the Oracle NFT is available there, which is going to be unique. So that way we could be sure that that data that's coming from an external source is authentic. This happens where we use Oracle, like if you have heard of Charlie 3 protocol, where they depend on external information, and they have NFT minted for every endpoint. So that's actually the basic verification that have, and it's the most important as well. Okay, okay. So the next one is UTXO contention. It isn't a security exploit, but rather like I would say, a denial of service. So, no, it occurs when multiple users try to interact with the same single UTXO at the same point. We would have seen the DEX is operating that way. So now, whenever you build the app or a DEX, you should be aware of this situation, and you have to, make ways to minimize by giving either parallel transactions, or you have to have some distributed state management so that every uh, UTXO is not being barged by a lot of users. So that is the other major one. Uh, yeah, I think that's all I have from the list of vulnerabilities. But if you have any questions or feedback, feel free to ask. I highly recommend to read through that MLabs uh, vulnerabilities list. There are actually two more which I haven't covered, but I think this would be sufficient for now. And as a starting point, this will be the major ones that we have to look into. So, thank you, Bernard, for sharing it again.
Mm.
Do you have anything to share, Bernard?
Maybe it's just to request your experience because you do smart contract audits. You have got that experience. Maybe you can share a little bit so that the developers, maybe when they are developing or planning, what could be the best
Uh,
approach?
sure. So, as I said, this is the first list that we will refer to whenever we have a project being audited. Uh, what we do is we first get kind of a commit hash from the client, and we fix on the code that's being given by the audit team, and we start reading line by line each code, I would say, or each file in the whole repository that's been committed there. So as we go through each line, mostly there'll be a few simpler logic that have been missed, but as you keep doing it again and again, you would eventually find some security leaks uh, that would be there. And when we code, it's easy to get uh, out of sight for those issues. But considering an auditor eyes, they look for each and every line. So it's a very a very crucial and a critical job to do, because we are actually trying to find what are the security leaks, or what are the major problems. So you should be very, very careful. Um, and the other interesting thing is, it's not done in one go. When you read the files for the first time, all you could figure out is basic logic or even grammar mistakes. But As in, when you do it again and again, you will critically see a lot of other bugs that was that was not seen. So I would say the first step to understand or to be an auditor is to have the list understanding of all the vulnerabilities list, and also to go back and check to the other audits that we already done. You will have another better idea of how to audit this file or other recommendations or other vulnerabilities that you haven't seen in this auditing. Question.
Thank you very much.
Good evening. Yes. How often do smart contracts have vulnerabilities? Like, how often do you see um, a lot of smart contracts having vulnerabilities? As in, okay, this is not right. And what are the common um, vulnerabilities that you see?
Okay. The common vulnerabilities are okay. Yeah, this unbounded data and unbounded value. These are common. And if I remember the other one, initially it used to be this token name, but I think now the understanding towards the asset class is more better. So I haven't faced this yet. The other redeemer is also a common one. Yeah, because it's easy to lose sight of this dependency logic on the other redeemer. But the most common ones are the bounds, the upper bound and the lower bound for in datum or the value.
Okay, thank you.
Yeah. And also, while auditing, the other crucial factor to mention is refactoring. No, as developers, we tend to write a code fresh every time. So we will don't remember that this code was already done. We could actually refactor it. So I think that's one major part as well, because we shouldn't be writing everything from scratch. When we have something already up, we should think about reusing that logic or refactoring or even having like a generic, generic function where you can use the same function to other logic or concepts.
So it's advisable to use whatever is existing, if possible, into your smart contract in order for you to prevent any type of errors, vulnerabilities that might occur.
Can you come back with that? I don't understand.
Or I'm saying that it's advisable to use other source codes. Let's say that I'm creating a smart contract for an NFT website, NFT marketplace. So I rather use certain functionalities that I might need, and like I might take certain functionalities of existing smart contracts which have already been audited onto my system, onto my smart contract. Like, is that advisable? That's what you're saying when
Yeah,
you.
yeah. Yeah. That I mean, that I think that's the major reason where open source projects are being audited. As you said, yeah, it's good to refer or it's good to have that as a bait and build upon it. I see some chats from Muhammad Asraful, but uh, I'm not sure. I don't understand this. Is this a question?
Yeah, I tried also to check. I couldn't
Oh,
understand if it was a question or a contribution. But I think from today, that was a very valuable presentation. Thank you so much. If anyone doesn't have any question or comment, let's appreciate this auditing process in our smart contract. Yeah, thank you.
Thank you
yeah,
for
if
the
you have any
presentation.
questions,
Yeah,
thank you. Ellen.
right. Thank you very much. Stop recording.